Hello everyone, my name is Bhavish Lohar and I welcome you on my YouTube channel Quest Achiever. So today is our topic basically control system. So I will be taking basically a GATE previous year question based on it. So first I will clear the concepts and then we'll proceed with the questions. How to tackle the questions. Okay, so let's begin guys. So this is our question. So let's begin. The block diagram of the feedback control system is shown in the figure GATE 2021 question. So basically the given figure is basically a block diagram. So you have to reduce it and you have to need to basically you need to find out basically a transfer function. So transfer function represents output by input. Okay, so first you need to understand how you can solve it. See, there are two methods that you can solve this block diagram. That you can use the properties of block diagram, or you can directly go with the formula like Mason-Gain formula. Okay, so this is a Mason-Gain formula that is represents as transfer function is equals to pk del k upon del. Okay, so pk represents basically a forward path from input to output. Similarly, del k represents basically a path factor, corresponding path factor for the path upon determinant. Okay, so this all terms will be clear more when I solve further. Okay, so I am solving further. Okay, now this is basically a summing points which is represent in Mason-Gain formula as a dot. Same, this is dot and clear. This is the feedback part. This H representing the basically a feedback part which is coming from output, this point to and moving backward side, means that is the feedback part. Okay, so this is, you have to write minus H and it is written G1. Nothing is there in between this, then it will represent 1. Okay, and this is y of s. Clear? This is y of s and this is basically a input, that is x of s. Similarly, in this you can write how simple is this basically. See, all this thing, that is the block part, has been reduced into the basically a line. Basic lines, curved lines are there. Okay, so feedback and this is the forward path is there. Okay, so now I will be name all these things. Okay, so this will be better for understanding purpose. Okay, so I am naming it for. Okay, so now this is x1, x2, x3. Okay, this is how you can name it. Okay, so now if you want to find out the basically pk, so pk is basically what? K is like varying from 1 to n. N means how many path till how many forward path are there. Okay, so n is the last one. So suppose p1 we have to find out forward path. So this is 1. So forward path, how we can write forward path means from input to output. So x1, x2, x3 till the output. Okay, similarly we have two forward path. See, this is the forward path which is not entering back to this input. Similar way this is also a forward path. So how you can write it? x1, x3. This is how two forward paths are there in our block system. Okay, so similarly you can find many more paths if it is present. Okay, now here in currently we have only two forward paths, that's why I drawn. Okay, now correspondingly for this you can find a del k. So similarly I told you that before that del k represents the path factor. Okay, so how to find the del k? Okay, del k. Now finding for the del k, so first we have to go with the p1. Okay, so p1 represents x1, x2, x3. So this you have to remove it. Means if you remove this path, suppose if you remove this path, this is your input x1, x2, x3, and this is your y of s. If you remove this path and see what are left with this, this is left and this is left. See, in this no closed loop is there. What is the main funda of finding the basically del, that is del k, okay? So del represents 1 minus sum of individual loops, okay, plus product of their loops if any more there are there, okay, minus, see this is two non-touching loops, okay, L1 and L2 represents non-touching loops, okay. Similar way we have to find out this basically L1, 3 non-touching loops, then so on, then 4, 5, 6, and you can do it, okay. So del represents again 1 minus sum of individual loops, okay, which are sum of individual loops, how many loops you can find out, okay, plus product of sum of loops, okay. So these two L1 and L2 are basically non-touching loops, okay, they are not touching. So in this case del 1, if you need to find out, so what is the value of del? So del basically 1, there is no loop, okay. So there is no loop because it is not forming in the loop, because it's just forming a half curve, it is not a closed curve, okay. So this is basically a 0. So, and similarly there is no product also will come, so this is equals to 1, okay. So basically the del 1 value is equal to 1. Clear? So some important parameters I have to note it down, okay. So this is basically a takeoff point, Similarly this cross is called as, I can write here, summing point, okay. So you need to remember what do you mean by the dot, okay, and what do you mean by basically the summing point. Similar way you need to write basically the x1, x2, x3, you have to write basically the gain, okay. So how x1 is g1 and only g1 is there, so g1 will come, okay, rest all 1 is there, okay, 1 into this also is 1. So similar way we have to write this, so 1 into g2, that is g2, that you have to write, because in finally the answer we want in terms of g1 and g2. This is the basically x1 and x2 basically are the notation that indicates that it is moving from input to output towards the forward path, okay. So now the basic thing is there, g1 and g2 you need to write, that comes under the answer, okay. This is basically a second path, okay. So x1, x2 and x3, okay. So this we are doing basically for finding the del 2, okay. So del 2 we have to need to, okay. So how we can find basically del 2 is 1 minus sum of individual loop, okay, sum of individual, there is no loop inside this, see this is not a complete loop, okay, still it is open from this side. So we don't have in this case a single loop, okay, that's why we can't proceed for the further, like this will come exactly to 0. So and similar way the product will not come, okay, product of 2 loops, product of 3 loops will not come, so this is basically a 1, okay. So what I did basically here, this is my part 2, right, this is my part 2 that I traced, okay. I traced in basically the previous case that how I represent the whole graph, okay. So for finding the basically del 2 you have to remove that basically part 2, that is this is the part 2 that I have removed, and which is left, these are the left part. See this is the main thing here, that it is not closed, okay. Sometimes it happens like this is like you have to close and this form a loop, but it won't, okay. So please take a precaution at this point, at this is not a closed path, that's why it is basically a 1 minus 0 only. Now similar way we have to find the del, this is the whole determinant, okay, graph determinant. Similar way you can find out basically 1 minus it is like similar to the path vector only, but this is like you have to consider each and every path in this case, and so on. Product of 3 non-touching loop. Okay, and this can continue so on. So we have only one loop in our graph, so I am writing this minus G1H, and we don't have 2 non-touching loops, so you can't product it, or even we don't have 2 loops also, so the final is G1H. This is how we can find basically a graph determinant. Now what we need to find basically a transfer function. So how you can find the transfer function now? So transfer function is del k pk, or pk del k you can write. Okay, so this is like basically a 1 to infinity you can say, or 1 to n is like defined. Okay, so now basically we have 2 paths, so you have to write basically del 1 p1 or del 2 p2, the whole divided by del. Okay, so now what you need to write basically, see infinity इसमें not कि infinity होने वाला है, it's a finite value only. Okay, many time in the graph you can get n is equals to 5, 4. Okay, so 5 path, 4 path, it comes like del. What is the value of del? Is this del 1 is 1, path is forward path 1 is this, similar 1, del 2 is this 1, and p2 is, that is g2, and hold upon g1. So now what is basically our total final answer? g1 by g2, g1 plus g2 divided by g1. So this is basically a final call of transfer function. Okay, so that is you need to find out basically. So see, the transfer function, there are many ways you can find out, but in control system there is a 2 way that are majorly used, like Mason gain formula, that is simple, but you need to understand what is the forward path, what is the feedback path, and graph determinant. Okay, many times the students make mistakes, like what happens that कि कौन सा loop बन रहा है कि नहीं बन रहा है, that is the main thing. See here in this case we have a clue, like students can get confused in this case, that is this close, that you can consider this. But see, this is basically a forward path which you have removed, so this is not forming a complete loop. That's why please take care of this point. Okay, this is the main thing, and then finally we conclude of this point that g1 से multiply कर दिया 1 से, and plus 1 into g2 whole divided by the total graph determinant. That's how we find out the basically our transfer function. So please see once again that how you proceed with the questions, and see each and every point, because this is in the GATE exam, many things you require, like it is not like मैंने question पढ़ा answers आ जाएंगे. You need to remember each and every point properly, and then accordingly you can proceed with your question. Okay, so please see this. Okay, and thank you so much. If you like this content, what I have did basically, okay, so please like and subscribe. Thank you so much.